It's not every day that we get to feature a promising new crop on this show, especially one uniquely suited to convert dairy manure into a high-quality, protein-rich, palatable feed.
They're very effective nutrient sponges, so to speak, and they're making something that's really upgraded. You can't take that liquid form and turn it into something valuable on its own without spending a tremendous amount of energy, but you can have these plants really leverage that material and turn it into a high-quality protein and starch.
That's Jason Prapas, founder of Fyto, which is pioneering the commercial production of aquatic plants that are not only nutritious for animal feed, but also highly productive.
Typically, it's going to be 8 to 12 times more biomass produced per acre per year than the leading land crop that you would grow, for instance, alfalfa or canola.
But to truly make their mark on agriculture, Fyto will need to scale.
It's not just about aquatic plants being great, because people have known that for a long time. It's about setting up from the ground up a deliberate system that tends to these plants the way that they've evolved to grow and takes the sting out of farming them for people in a cost-effective way.
Are aquatic plants the answer for converting animal waste into animal feed? Fyto's Jason Prapas on today's Future of Agriculture podcast. Hello, fellow Ag Nerd. Thank you so much for joining me for another episode of the Future of Agriculture. My name is Tim Hamrich, and every week you and I get to hear from the founders, farmers, innovators, and investors shaping the future of the ag industry. I have another fascinating episode lined up for you here today, but right before we dive into that, I want to take just a moment to thank our quarterly presenting sponsor, which is Calgary Economic Development. Now, what makes Calgary, Alberta, the engine of Canada's agriculture industry? Well, with direct access to a strong agricultural base, Calgary is a well-connected region with collaboration across geographic areas, industries, and research and training institutions. Calgary has experts in all things ag, including primary production, crop science, protein development, ag and food tech innovation, and animal health. It's also a hub for controlled environment agriculture, energy transition opportunities, and value-added food and beverage processing. Calgary is a hot spot for agri-food production and technology development, which is why multinational agribusiness leaders call the city home. In Calgary, they're leading the agribusiness revolution, and you, that's right, you, are welcome to join. Visit calgaryagbusiness.com to learn more. That's just calgaryagbusiness.com. And thank you so much to Calgary for supporting the Future of Agriculture podcast. All right, now back to today's episode with Jason Prapas of Fyto. Jason and I are going to discuss the systems that they're developing to commercially grow aquatic plants. Now, we're not talking about algae here. I know we've done a couple episodes on algae on this podcast. This is not another algae podcast. As Jason will explain, their focus right now is growing a very small plant that's related to what's commonly known as duckweed. Fyto's in the process of setting up their systems on dairy farms to grow this crop in the effluent from the cows and have it immediately readily available as a high-quality protein feed. Jason's going to explain what makes these types of plants unique and important and promising for the future of agriculture. I personally learned a ton from this interview, and I think you might learn a thing or two as well. It's super interesting stuff. Jason has a PhD in mechanical engineering, and prior to Fyto, he was the director of translational research at the MIT Tata Center for Technology and Design. There, he led the center's efforts to select, shape, and position projects for large-scale development, and helped develop 8 spin-out companies in 18 months across energy, health, agriculture, and water. He was also an instructor of entrepreneurship courses at MIT Sloan School of Management. Now, prior to that role at MIT, Jason was the co-founder and CTO of Factory Ventures, a venture development and investment firm. Years ago, he also worked as a process engineer for the world's first algae to biofuel company, Green Fuel Technologies. That might be a little confusing because I just said today is not about algae, and it's not. I'm going to hold to that, but that is his background, and you could start to see some of his interest develop into what is now Fyto, working with aquatic plants. Notice the distinction. So as you can tell, he's really approaching things from an engineering perspective, but with a deep background in entrepreneurship, innovation, and science. Exactly the type of person we love to talk to here on the show. So enjoy today's conversation with Fyto founder and CEO, Jason Prapas.
We started as a company about 4 years ago, but I've been growing unusual aquatic plants for over a decade, first as a hobby, and then more professionally, really in the last few years. And I think some of that draws from inspiration I had growing algae for biofuel production as my first job out of college, which really got me hooked on alternative cropping, on bioreactor design, on pairing biology with engineering. So I really liked that aspect of that work, and I think clearly it's sparked some interest later in my career.
And is this one specific type of tiny plant you're growing now, or is it multiple varieties?
It's multiple varieties. We see this really as a platform for automated production of aquatic plants within quite a wide variety of applications. Obviously, you have to focus somewhere when you're starting as a small team. And we're looking at a variety of lemna, it's a type of duckweed that has a really good profile for feeding dairy cows in particular. So we've hunted around for natural varieties until we found one that really had a good yield in terms of annual production, but also a really great composition for dairy cow nutrition. We have had other plants and continue to grow some in our biological library that are better fits for poultry production, for instance, some that have all the essential amino acids for human nutrition, others that are really great fits for potential biofertilizer applications. So again, we have to focus, and we're focused on dairy feed to start, but we have some breadth in what we can address with these other varieties of aquatic plants.
That is interesting. And so I imagine because they're a tiny plant and they grow in water, they're often confused for algae. Is that right?
Yes, I get that question a lot. And to me, it's a very important clarification because I used to work in algae and I decided I didn't want to do that anymore after that experience. I think algae can be really an amazing organism or platform. It's many organisms. But I personally wanted to do something that I thought could have more immediate impact. And there's some distinct differences between a macrophyte, which is how these plants are categorized, and microalgae. And just a couple of those distinctions. These plants float on the surface of water and they prefer still environments. And those two characteristics alone mean you can have some tremendous advantages in terms of engineering an automated process around them for farming them that uses much, much less energy. So we don't need to be constantly moving our plants around so that they get access to their nutrients and their sunlight, which you do need to with microalgae because they grow in the water column and they have to be stirred around, so to speak, so that they get access to their sunlight for energy and their nutrients that are, one of the major nutrients is carbon dioxide that they're pulling from the air in the headspace. But these plants float so that they naturally access those things. It's also a huge advantage when you're looking at things like, how do I harvest out of this tank or out of this pond? And because they float, they're naturally separating themselves from the water, which makes it much more amenable to automation.
That is really interesting. So, but where my mind instantly goes is, all right, we've got these very, very tiny plants on the surface of water, and we're going to feed cows with them. And I have a sense of how much cows eat. It's a lot. So, what kind of convinced you that economically you could produce enough of this that would make sense to grow it for cattle feed?
Great question. And you're right. Cows do eat a lot. And if you sum it over the globe, just looking at the king of protein, which is soy, collectively livestock are responsible for over 70% of the consumption of soy that we grow as a species, as humans. Cows are a big part of that. Poultry are a big part of that. I led with these are the tiniest plants, but maybe the most important metric is that they're arguably the highest yield plants on the planet in terms of what they're capable of. If you put them in the right environment, if you give them what they need at the right rate, they can double every 3 days year round in the right climate. And we've been able to experience that now for several years in a place like sunny California where we're based. And the truth is there's going to be geographies where these plants are not as productive as they can be in other places. But in most places that you might grow something, if you try putting these head to head with the land crop, they will almost always win in terms of mass that's produced per acre. And what's really interesting is if you find the varieties that have the nutritional composition that you're looking for, they can really outcompete kind of status quo crops. So we're looking at how can we make not just crude protein, but protein that has the amino acid profile that's great for dairy cow. And we compare that to the types of crops that folks are growing for feeding cows. That's things like soy, canola, cottonseed meal is getting more and more traction. And if you look at the nutritional composition, our lemna looks fantastic when we speak to nutritionists in terms of on paper, it looks great. But the next question is, yeah, but how much can I grow per acre? And that's an even more exciting answer, because typically it's going to be 8 to 12 times more biomass produced per acre per year than the leading land crop that you would grow, for instance, alfalfa or canola. So it's exciting that it's such high yield, but that's also why we had to design an entire new platform for farming it, because you cannot process a farm in terms of harvesting it, feeding it, and turning it into a product that a cow will eat with manual labor and expect the economics to work. So we really had to build the automation solution around this.
Wow. Well, I want to get to that, but before we do, I know these dairy producers, they don't just feed biomass, right? They want the protein and the fat and the fiber content to be just right and the amino acid profile to be just right. How does that look for Lemna?
That's right. So dairy producers and the nutritionists with which they work are acutely aware of what a cow needs to produce milk day in, day out. And one of the things they're looking at is how can we fine tune what's called the ration, the total mixed ration for these cows, the diet. And it's a combination of analytical methods and software that nutritionists use to make educated guesses as to what's going to happen. But then most importantly, feeding cows in things like trials where you're tracking how is this cow performing, what is the production of milk looking like, and also what are the components within that milk, because that's how the producer is paid. It's not just on volume of milk, but it's on the butterfat content within the milk, the protein content within the milk. And that, as you can imagine, is a direct result of what the cow itself is eating and how it's processing what it's eating. And in every case that we've tested, we've seen excellent palatability of the product, which is number one factor. Is the cow going to eat it? And you might think a cow will eat anything, but the truth is they like to sort. You can see them pushing feed that they like toward them and pushing the ones that they don't away from them. And so palatability, we were able to do a checkbox early on, but more importantly on safety and efficacy, we've seen the heifers, which are the adolescent cows, have substantial weight gain when their substitution of their usual protein with a phyto diet is taking place. And that's led to the dairy farmers we've worked with being very excited about what it could mean for their operation, saving money and having better performance in terms of heifer growth. And on the milk trial side, we're doing a really rigorous study right now where we're tracking, again, not just the milk production in terms of volume, but the components of the milk. We're also tracking enteric emissions, which is a really important topic these days in terms of methane production from the animals themselves. We've done in vitro tests in test tubes with rumen fluid from dairy cows that demonstrated a potential 20+% reduction in enteric emissions. But we want to see that in live animals because a test tube is not a cow. And we recognize the difference, and we want to see what happens over the long term when we feed cows the diet and see if that metric is also improving.
Right. In the total mixed ration, this is theoretically taking the place of the high proteins like a soybean meal, canola meal, cottonseed meal.
Exactly.
Cool. Well, yeah, and I know you said that research is ongoing, and obviously that's really, really important and foundational research for what you're doing. But I do want to pivot to the economics a little bit. You say this could potentially produce 8 to 12 times the biomass per acre of a field-grown equivalent crop, which is great as long as you can produce it at less than 8 to 12 times the cost of that crop. And so how have you approached that situation?
Yeah, so this is where there's some really exciting opportunities for engineering and for our plant science team, because it's really an equation where you're looking at how do I make this plant happy in terms of producing more and more of itself at the composition that meets our requirements for quality and for nutritional composition that the dairy producers are looking for. And then how do I put the tools and the infrastructure around it that allow it to continue to operate year round or close to year round? And that really is an interdisciplinary problem. In some ways, the plant scientists are the customers of engineering on our team. And obviously the customers to Fyto are dairy producers. But the plant scientists tell the engineers, this is what it needs to do to be in its optimal state of reproducing as a plant. And the engineers get to work thinking through, okay, we could do it this way, we could do it this way. And everyone on the team has an acute awareness that this has to be cost effective. There have been an innumerable list of things that we have rejected as options because we realized from the outset that could work, but it would never be feasible at scale. And so we hold ourselves to that discipline as a team. And I think what it's manifested in is the ability to say with a straight face, we can produce a metric ton of material, for instance, at close to cost parity already as a very small company with the incumbents, something like soy or alfalfa. So on a per pound, how much does it cost to produce this? It's pretty simple to look at what goes into the cost of production of a crop. It's labor, it's energy that was either in the form of fossil fuels to run vehicles or electricity to convey material. It's water if you're paying for water. We always, in our models, assume that we are going to pay for water, even if it's not necessarily monetized in every place. But it's a resource, and we think there has to be a cost associated with that. And then it's land rental or land ownership. And so if you start to compute all these things, you can get to a pretty accurate cost of goods in terms of producing a pound or a ton of material. And we're really excited about where we're already at on that standpoint. We have a lot of work to do to make sure it's more and more automated and take labor out of the equation. But actually, the battle really is on capital equipment. So how do we make sure that the machinery that makes this all run and makes the cost of production really low is also going to pay itself off in a reasonable time frame? And that is very achievable, but there's work to be done. So we're very focused on two aspects. How do we have one robot that's basically the digital farmer of these aquatic plants serve more and more acreage per robot, because that's going to really reduce the cost per acre on a CapEx side. And that you have to look at things like, what is the method in which I'm harvesting? Because it's driving around autonomously, and that has a certain power requirement. But what it's doing in each spot is also going to sum up to, the energy cost and how often I need to charge this vehicle. So we're looking at the systems approach to cost reduction, which is a combination of CapEx, OpEx, and just we want it to be a maintenance-free or very low maintenance environment for the producer whose property this is going to be on or it's going to be nearby. And so we're looking at those parameters as well. How do we have this be really kind of running itself over time? Because that's going to be an important aspect versus going to a dairy producer and saying, hey, how would you like to become an aquatic plant farmer? Most will say, I'm pretty busy. So could you handle that for us?
Yeah. So how does that work? Now, it sounds like it's decentralized, like you want to put a facility, and is it like a greenhouse type facility? You want to put one there, but also you want to help the dairy producer, in this case, operate it? How does all that work?
There is flexibility. What we've done thus far is imagine that the bulk of our installations are going to be on livestock operations. We've found many properties and had the fortune of visiting with great producers that are excited about what we're doing. They have access to land. They have access, obviously, to the manure that's the main feedstock for our plants. And in many cases, they find that manure to be a problem, both for compliance with state regulations, but also just they've applied a certain amount to their crops, the other crops they're growing on their farm. And when that reaches the amount that they need, they have to dispose of the rest. And so it's really a cost. So there's a really great circularity to setting up on the operation itself, because you're solving two problems for the dairy producer and you're solving two problems for Fyto. The two problems for the dairy producer are waste management and feed production, two things that are at least on the top 3 list of things that dairy farmers worry about on a daily basis. And then for Fyto, we have a feedstock partner, which is we have our manure, that's our fertilizer for our plants, and we have an off-taker for the products that we're growing. So it's a really synergistic, circular nature of the operations when we can install on-farm. It's also true that we could set up near farms, and we could have either a pipeline of effluent from these operations, and there's precedent for this. You're seeing anaerobic digesters that have pipelines both for the feedstock and for the biogas that they're producing. And I think it's important to maintain that level of flexibility for now until we see how we can best scale. But we're excited about the opportunity to serve both on-farm and near-farm. In terms of what does the system look like, you ask a great question. Is there a greenhouse? We have grown in hoop house structures, and that provides a more controlled growing environment and, frankly, a longer season if you have cold nights, like in the winter months. But in this effort to really reduce CapEx per acre, you have to look at the trade-offs. If I put a hoop house over something, it's going to be more expensive than if I don't. And you have to look at, does the extended season that affords really make sense on a dollar and cents basis? Sometimes it does, sometimes it doesn't. So we have systems that actually don't require covering. And what we have to do is just make sure that we can deal with wind, for instance, because these plants, as I mentioned earlier, really prefer a still environment. And if they're getting blown around, it's really just taking away from their yield potential. And so you look at different ways you can block wind, and there's some very cost-effective ways that don't require covering. And then you're just looking at keeping out potential invaders like the wild birds I mentioned that really like this stuff naturally. We can just put a netting system over our tanks, and we can have control over the off-takers that did not sign up with Fyto for our product, such as ducks and geese.
Keep the ducks out of the duckweed.
Exactly.
Yeah. Well, you mentioned manure being the primary input. I mean, is that the only input? Is it kind of seed and manure, or what else goes into a system like this?
Yeah, for several years, we've been able to grow successfully off of just manure. And I think it's important to make a distinction about what I even mean when I say manure, because a lot of times people will say, well, manure is really valuable and it's used. And that's absolutely true. There's a lot of nutrients in manure that are being used in row crops and other crops now. But what's important is that's the solids side of the manure equation. On a dairy farm, you typically will have machinery or processes that separate the solids from the liquids. And the reality is the bulk of the nutrients are actually in the liquid form, and it's very difficult to transport those off the farm because it's mostly water. So your ideal use case would be something that can use nutrient-laden water on site versus trying to find ways to dry out what is mostly water and transport the remaining solids, or pipe it somewhere far away, or take it off with trucks. And taking it off with trucks has been the predominant solution to meet compliance. And it's not friendly from a cost perspective to the producer, and it's not friendly to the environment from having to have all these vehicles, parading around water to dump sites. So these aquatic plants present a really unique opportunity to use manure that is not the manure that is predominantly being used in other forms in agriculture. That's the solids that are being composted and applied. We don't really compete for that resource because those are not the form that we're using. We're using the liquid form that's in the lagoon or coming through a digester.
Still, manure water sounds stinky to me. Is it? I mean, do these plants really kind of clean it up, or kind of what is that? How do you manage it so that it's not just a lagoon, like a lot of problems we're having with lagoons, in many parts of the country?
Yeah, you're not wrong about the smell that tends to happen from lagoons, but you get used to it. I can assure you that. So the reality is the effluent, as it's often called, that's in a lagoon, it's gone through the animal, and so it's got to have some level of nutrients because an animal is not 100% efficient at capturing everything. And those nutrients can be recycled and often are. So some of these lagoons are piped to drip irrigation systems where the dairy farmer or a nearby farmer is actually irrigating and fertilizing, or what's called fertigation, crops directly from that feedstock. And so there's decades of precedent that this is an effective and safe source of nutrients and water for crops. The issue is, unless you have a tremendous amount of acreage, a cow, as much as it eats, as we discussed earlier, it also has a lot of waste each day. And unless you have sufficient acreage, you're not going to be able to uptake with a standard crop the amount of nutrients that remain in that liquid form. So our plants, because they're the fastest growing plants on the planet, and they make a tremendous amount of protein if you pick the right variety, the building block for protein is nitrogen. And because of their speed of growth, they are incredible absorbers of nitrogen from water. They're absorbing other things because they're plants, so they need phosphorus and potassium and calcium and iron and other micronutrients. So they're very effective nutrient sponges, so to speak, and they're making something that's really upgraded. You can't take that liquid form and turn it into something valuable on its own without spending a tremendous amount of energy, for instance, to dry it out and turn it into a fertilizer. But you can have these plants really leverage that material and turn it into a high quality protein and starch, plant-based material. So it's very good at cleaning up the water, but it's really recycling that's already been demonstrated for decades, just done on warp speed because of the ability for these plants to grow much more quickly.
Yeah. I mean, it kind of reminds me of, we've had stories of black soldier fly larvae on the show before. I mean, it's kind of a similar concept just with plants, right?
That's right. Yeah. And I'm a big fan of a lot of the other players in this space looking at alternatives. And we don't really compete with insect companies for cows because cows are herbivores and they need plants. And I think that some of these other companies, like insect companies, are dealing with some of the same challenges I'm sure that we do, which is biological organisms are sensitive to certain things, and you have to maintain optimal growing environments, whether it's an insect or a species of duckweed. We have different challenges on that front, but I think we probably share some of the headaches that come up when suddenly your feedstock changes and you have to make adjustments. And I think we're going to learn from each other as an industry, which is really exciting, having several dozen companies really working on similar problems at the same time.
Right. Although the way you're setting this up, your feedstock should be extremely consistent. I mean, from the dairy feed has to be very consistent. The dairy conditions have to be very consistent. So I imagine what's coming back to you is very consistent. I know you called them nutrient sponges, which is so great. But is there anything that they aren't uptaking that you have kind of an offtake of, some sort of byproduct of the process?
Yeah, great question. You're right that we do have relatively good consistency year round, with some variations. When you have the rains that we had in the last few months in California, it can dilute your nutrients and then you just have to adjust the feeding rate. And that's relatively straightforward, but you have to have the sensors and the actuators in place to be able to deal with those changes on a day-to-day basis. As you can imagine, every plant on the planet has an ideal growth media, an ideal set of nutrients that would be the perfect match for its growth. And in reality, nothing is that unless you were to formulate it each day. So what we've found with the effluent from dairy farms paired with the lemna variety that we're growing is it's an excellent match, but it's not perfect. So we have to keep an eye on which components are getting taken up, which components could potentially be deficient, in which case we'd have to adjust the feeding regimen, the frequency, and then, of course, which components might be in excess. And duckweed is actually pretty famous in the academic literature for being very flexible to a wide range of components within its growth media. But again, that doesn't mean that it's a perfect blend each time. You really have to look out for certain ions accumulating. What that means is there's a version of Fyto that's actually continuous mode. And so think about it as we're getting a feedstock in, which is this diluted form of effluent from the cows, and we're sending back a nitrogen reduced and many other components reduced stream to their water storage area. And they have, on a dairy farm, huge water storage areas for accumulating their waste and irrigating their fields, because many of them are growing things like corn silage or forage for their cows. So we're actually just borrowing the water, taking away something that they're getting, in many cases, fines for applying on their soil, and returning it in a form that's even more useful to them. And that's another reason why it's really a great synergy to be on these livestock operations, because the infrastructure that we need to run our system, where these different components are in good balance for growing our plants, already exists on these dairy farms. We're just a process that kind of plugs into, downstream of the lagoon and also sort of upstream of the lagoon, where we take some from it and we put a dilute form that's got the nutrients reduced and valorized into protein back into the lagoon.
Great. Yeah, no, and that actually answers another question I was going to ask you, which is about the water requirements, but borrowing the water is a really good way of framing that. That makes a lot of sense given the system you're plugging into. Are these grown from seed? And then along with that, what agronomic issues do you need to watch out for in terms of pests or diseases or, other plants that want to colonize your ideal conditions for aquatic plants? Talk about what I'll call the agronomic or horticultural challenges of growing this crop.
Yeah. So we don't have seed, which means we don't have a unit operation that is, equivalent to sowing seed in the field. These plants reproduce predominantly vegetatively, so they're budding off of one another several generations before the plant eventually senesces. That actually is a huge factor in deciding how you would design an automated platform for farming it, because In one way, what you have to do each day to keep the system humming and the yields high is thinning out the herd, so to speak, of duckweed each day by getting to every spot where there's been new growth, removing the right amount to bring it back to a level where it can continue to repopulate. And as you can imagine, there's a sweet spot where if it's over-harvested and you have sparse colonies of these plants, you're going to have an atmosphere that could support competitive crops coming in, for instance, algae, which are not necessarily problematic, but if you're trying to grow a crop, you want it to be that crop. And so you have to really keep it in that high enough density zone where it's a very incredible, effective competitor against other crops. A, because it's in water, and so most crops won't grow super effectively in water, but the ones that do, such as an algae, always need that access to sunlight and CO2 on the surface. If you look at our plants, they form a dense blanket and really block out light that prevents competitors from getting an edge and reproducing under the surface. They've evolved to be their own, shield against competitors by floating. That's really been demonstrated to us over the last few years of just how effectively they can compete against a wide variety of aquatic organisms. So in terms of the other agronomic aspects of this, you don't need to seed, but you do need to keep those, the density in that sweet spot. If they get overcrowded, you have an issue of some of the plants are now crowding out their own friends and neighbors of other lemna. And that just leads to, quick senescence of those plants that didn't get access to their sunlight and CO2. You have to feed them kind of at pace with their growth. So, it would be really great if we could just feed them a fixed volume of nutrients or fixed mass each day. But if it was sunny on Tuesday and cloudy on Wednesday and sunny again on Thursday, you really have to adjust according to those weather patterns. And again, we have such an advantage in the way that these plants grow and in the way our technology was designed to address them, where that's not a problem. We can say, here's the historical weather data for this week. Here's what we've seen in past weeks, not just from this operation, but from our database of other operations in the area. We should feed it this much today because that's where we saw historically the best performance. And so you can really see that these different installations will leverage each other and the historical data that's being collected to have a network of knowledge across these automated farms that might sound like the thing of science fiction, but is really, and not just with Fyto, many other companies are starting to see what's possible when you have these connected devices. And in our case, it's not just about the data, but the actuation of our machines is very straightforward. They just have to do a couple things really well. They have to harvest and they have to feed and they have to sense where the plants are. So those are the things we've really been focused on, and we've been able to get several of those things patented because this is a very new area for farming in terms of aquatic plants.
Yeah. All right. Well, this is maybe a little bit semantics, but it'll help me kind of use the proper terminology. The company is Fyto. What do you call the product itself, and what do you call the system itself? Or do you call those Fyto as well?
I'm not a marketing person, and so we need to have names for them. We don't have any trade names for them yet, but Fyto is, and this is also portrays that I'm maybe not the most creative with terms. Fyto is just the Greek word for plant, and on my dad's side, I'm Greek, so, it seemed like a good name for a company that's growing plants. And in terms of what we're growing, because it's a variety of different crops over time for different applications, they won't be called, Fyto, because that could mean a number of different things. The dairy feed crop that we're growing is a lemna variety, lemna minor. We have other crops that have very different characteristics in terms of how they process nutrients. So we have a crop that's a nitrogen fixing fern called Azolla. And what's really interesting about that is it really flips the value proposition on its head in terms of nitrogen. If you have too much nitrogen and you want to absorb it, lemna is a great choice. If you don't have enough nitrogen and you want to get leverage of the phosphorus and potassium that may be in your water or in your waste stream, Azolla is a really compelling choice because it pulls nitrogen from the air in addition to carbon. And so it's like a cover crop that you'd see people planting between seasons because they're nitrogen fixing. But again, it's so much more productive that you're going to get 10 to 20x the nitrogen capture that you would with a land cover crop. It's really exciting to us that we have two pathways for nitrogen. If you need nitrogen, we've got an answer for that. If you have a nitrogen problem and want to valorize it into a protein, we have an answer for that. And within those categories, we have several species that have different compositions for different applications.
Very cool. Wow. Well, I think I know the answer to this, but just to make sure I clarify, is the reason that this just really hasn't been done in the past the economics of trying to do this efficiently? And is that where kind of the robotics really is the key to it all?
It's a really interesting question because it's one that I wouldn't even say I have a definitive answer to yet. I have some hints from from the decades of work that have been done looking at aquatic plants. And I'll share those with you, but I'll say that it's also for us to discover if we've actually unlocked the key. So there are economic challenges in the past that have made aquatic plant production tough to compete with some of the other commodities. So when you had more rampant use of synthetic fertilizer without thinking of the long-term implications to the soil health or the environmental issues associated with that, you could get short-term yields of things like corn and wheat. And if you had lots of land and a combine tractor, you could fertilize thousands of acres. And this is still happening, obviously. But people are starting to get more savvy about how long can we do that for before there's some real challenges here. Running out of land, not having more forest to deforest to grow more, commodity crops, having more concern about what's happening with this fertilizer and if it's fossil fuel derived, whether that's really something we should continue to consume. So the timing is right in terms of general awareness that, if there are better ways to do some of these things, we should really be investing in those and looking at those. And so the timing, I think, is just luck in our favor. But from a technical perspective, I'd say so much of what I've seen done in the past was sort of serendipitous discovery of aquatic plants being useful and people kind of taking them out of ponds, feeding them to ducks and chickens, and having peer-reviewed literature that indicates this could be really great. And in many of the conclusion sections of these papers, and these go back to the 1950s, 60s, 70s, all around the world, but many of the conclusions are really pointing to the same problem, which is until someone designs a mechanical, automated system for tending to these plants, it will always be too labor intensive. And so we really set up the company on the premise of two things. Aquatic plants could be incredible. They clearly have demonstrated way before we got involved that their yields, their composition, if you pick the right ones, their palatability are very exciting. Their resource use in terms of much less water, much less, off-the-shelf fertilizer required, in some cases none, like we haven't used any. But this mechanization, if you think about other farming platforms, if you think about how we grow corn, how we grow wheat, how we grow soy, and pretty much all the others, when they're not a specialty crop, we've developed automated or at least mechanized systems that can allow for fantastic leverage of a single human or a couple humans. We have to do the exact same thing for this, and maybe even more so because of how productive the plants are. And so we really set up the premise that it's not just about aquatic plants being great, because people have known that for a long time. It's about setting up from the ground up a deliberate system that tends to these plants the way that they've evolved to grow and takes the sting out of farming them for people in a cost-effective way. And obviously we have a lot more on that journey to accomplish, but we're off to a really great start, we think.
Absolutely. Well, I know obviously, the organic path seems to be a really clear one. Also, we've had Neutral Foods on the show about, the types of dairies that they're working with. I could see definitely a direct connection there. Where is Fyto today in terms of their company's development, and what's next for you in the coming months and years?
Yeah, so we're still an early stage startup company. We are in our Series A, basically. We raised our Series A last year, led by a fantastic group of investors. The lead was Google Ventures, which has been a really great partner for us. But we have many others that have been helping us along the way. So our real task in this stage is to prove that we can commercially produce these plants at scale, cost effectively, and that there are off-takers that are excited to get even more. What we can't do is serve the whole market, our lemna protein, because for reference, there are 1 million acres of alfalfa under production in California, the majority of them going to cows as their protein source and as a fiber source. And so it's going to take us a while to catch up to some of the incumbents, and we recognize that. We're humbled by that, but we're also excited for the opportunity as an underdog to to take on some of these incumbents. But the next stage is really going to be about, if we've had successful operations on a commercial farm, really scaling that up and having many more farms involved. And it truly is a partnership with not just the producers who are realizing the benefits on the waste management side and the feed production side, and also educating us on what could be better. How could this be more streamlined with your operation? What nutritional components would you like to see even more of? That's really important for us at this stage, to be educated by the producers that know this industry much better than we do. The other partners are the communities and the regional governments, the state government, even the federal government. We've had some really great visitors to our sites that can see the vision that we have and share it, that this could actually be on thousands of farms around the world if what we're saying is accomplishable in a reasonable time frame. So it's really up to us to prove to those audiences that have some early excitement for what we're doing that this is not a pipe dream. This is achievable, and we're ticking off, de-risking each month more and more of how this will work. And yeah, we have some challenges ahead of us, but we're really excited for the opportunity we've been given.
All right, well, that's going to do it for today's episode. Thank you so much to Fyto founder and CEO Jason Prapas for being on the show. Really did enjoy that. I highly encourage you to go learn more about what they're doing on their website, which is just Fyto. It's Fyto, Fyto.us. Go check it out. I know they've got some job openings as well for any of you out there looking to be a part of a mission-driven company like Fyto that's doing interesting work for the future of agriculture. You can check that out as well. Also want to thank John Farmer, who made the introduction to Jason and hence made this interview possible. Thank you so much to John for that. All right, thank you to Calgary Economic Development for being our quarterly presenting sponsor. And last but certainly not least, thank you for your time and your attention. I don't take it lightly. I'll be back next week with another story of ag innovation.